This is MATHguide.com. My name is Mark Karadimos, and we're going to take a look at a sine curve. This is a trigonometric function called sine that has two characteristics. Alright, so we have two numbers. Each number represents some detail regarding the graph. Alright, so what do the numbers mean? Well, the number here in front of sine will help us determine what the amplitude is. And then the number that's in front of our variable, which represents the angle, this number in front called the coefficient, is going to help us figure out what the period is. Alright, so let's get down to work. What's the amplitude? Well, the amplitude is the absolute value of this number. The absolute value is 3. Alright, now how do we calculate period? Well, we're going to take 360 degrees, a full circle, or we'll take 2 pi if we would rather deal with radians, but I want to deal with degrees. So you take 360 and you divide it by this number, 2. So 360 divided by 2 is 180 degrees. Alright, so that's our period. Now it turns out that this equation, this trigonometric function, only has two characteristics. So there is no phase shift, there is no vertical shift. So it'll be easier than those more difficult problems. Alright, how do we graph? Well, we start with the period. We go over here on the right side of the graph and we put a 180. Now we take those 180 degrees and we break it up into quartiles, in other words fourths. So 180, well, let's see, what's half of 180 is 90. What's half of 90? 45. Okay. What's the third quartile? Third quartile, well, add the first two quartiles together, 135. There we have it. Alright, remember our amplitude is 3, so I'm going to make 3 notches going up the y-axis and 3 notches going down the y-axis. There you have it. Alright, so when we graph, we are going to make some points. So I'm going to draw some points. And let's see, sine starts at the origin. So I'm going to put a point right at the origin. First quartile will go up to our maximum. Second quartile will be at the x-axis. Third quartile is going to be at the minimum. And fourth quartile back to the x-axis. Alright, so if I connect all these points together, which I'm trying to do with a dashed line to get a feel for how this is going to look, with a classical sine shape, it's going to look like that. Hopefully freehand I'll be able to sketch that out. So I'm going to trace those dots together, wavy hand and all, and I get better at this as time goes by. So we have this graph, and we have it all graphed out. You can see everything's busted up into quartiles. We have it all graphed. There's really not much more to talk about. Okay. Oh, we do have one more thing to talk about, and that would be the interval. When we describe the interval, we describe it with the first point and the last point. Sometimes this interval is kind of an important thing. It comes up here and there. Well, this point right here is pretty simple. It's the origin, 0, 0. So it's 0 degrees, 0 for y. And over here, you can see it's 180 degrees, comma, 0. So we would say that, well, where does it start? On the x-axis, it's, well, actually, for the x value, that is, it starts at 0. And then the last x value of this particular interval is 180. And we would write it like that. Yes, the curve does go on forever, left and right, and with duplicate patterns, left and right, just like this. But for this particular pattern, this period that we have graphed, it starts at 0 and ends at 180. And that would be the interval of this particular curve at this moment that we have graphed. Okay. So go to MATHguide.com, check out our other videos, interactive quizzes, and lessons. Take care.